is um, and it contains the basics of vectors, right? So first we have to understand that what is a vector, and perhaps this thing you must have studied much earlier. Do you know what are vector quantities? We should understand two things: vector quantities and scalar quantities. So, what are vector quantities, students? Let us write the definition. What are vector quantities? Anyone? Do you know? Vector quantities are those quantities which contains, these are the physical quantities. Which have magnitude as well as direction. Right, students? You must have studied this definition in physics. And physics only, you must have seen some examples of vector quantities also. Right? Do you remember? What are vector quantities? In which without direction the meaning is not clear. You know what are vector quantities examples? Anyone? Neha, what are vector quantities? No response. Khushmeena, what are vector quantities?
Sir, which show magnitude and direction.
Yes, like?
Sir, it means 30
30
degree north.
Hmm?
It means 30-degree north, 40 kilometer, like that.
Yes, yes, like that. And or other particular names you can tell, like force. Force is always with direction, right? Or momentum, or velocity, or acceleration. These things, when you study in physics, we always tell the magnitude with direction. Direction also we tell. Now the next term is scalar quantities. Scalar quantities are different from vector quantities. These are the physical quantities containing which contains which carry only magnitude. Right. For example, right, you must have studied. For example, speed. There's a difference between speed and velocity. Speed means only the number, the measure. Mass, yes, Neha. Mass. What else? Amplitude of magnitude of force, if you find it is a scalar quantity, or energy, right? Yes. And what else? Distance, that is distance,
volume.
volume, these all, density, these all. And many others you can search the examples. So this is now the notation for vector quantities is that vector quantities are denoted by some symbol we have to assign. Suppose A and then one arrow like this we make. This is the symbol of vector quantities. Or like this also we write, bar also we write. This is the way to denote B bar, C bar, F bar, F vector. So like this we show these vector quantities, right? If you want to show their magnitude, that can be denoted by like this, within modulus sign be enclosed, and this shows the magnitude of the vector quantity. Now there are some specific terms because we are going to use those terms again and again in our context, so let us know them. So there are some particular vectors which we use again and again, like unit vector. Right. So you can make a guess what should be a unit vector. It is a vector whose magnitude is 1. Right. And suppose one more work many times in the exercise it is discussed that a unit vector in the direction of a vector. Suppose any vector is there, a vector is given by. So what we do, we show it by a cap. Like this we read it as a cap or a hat. And this we denote by, we give by the formula. What you do, you write a vector and divide by its magnitude. But its magnitude, sometimes we write like this also. That remove the arrow. That denotes the magnitude. Enough. This is, then let us learn some more terms. One term we use multiple times is zero vector. Zero vector. It is, now zero vector means what should be a direction, but only for a concept we learn it. Zero vector means when magnitude itself is zero, what is the sense of direction? But as a concept, many times we suppose 10 unit vector is in north direction, 10 unit vector is in south direction. We add them, the resultant is 0. So in those sense, for those things, it is useful. It is a vector with 0 magnitude. With 0 magnitude. Okay. We denote it by this 0 vector. Okay. Then next is co-initial vectors. Can you make a guess? Abhishek or Sajbeen? Sajbeen Parveen has joined. Can you make a guess कि co-initial vectors क्या होंगे? Anyone? And इसी तरह एक और vector co-terminus vectors. See, co-initial vectors are, yes, saying writing which starts from same point. Yes, initial means initiative, means a start. So two vectors starting from same point. Suppose one vector is this, other vector is this. They are co-initial vectors. Two vectors starting from same point. Right. And similarly, coterminous vectors should be what? Terminal means endpoint. Terminal means endpoint. So coterminous vectors means two vectors having same endpoint. Like this. One vector is this, other vector is this. So vectors, these are the vectors having same endpoint. So this is because these terms will be used again and again, so it is good to know them and to write their definitions in our notebooks. Right. The next term we use is parallel vectors. And one more term is the name is there, and we'll discuss why that name also we use. First, parallel vectors. Can you make a guess कि parallel vectors क्या होंगे? सौरभ मीना क्या कोई guess कर सकता है या कोई भी और क्या parallel vectors क्या हो सकते हैं? जैसा कि नाम से clear है, it's clear from the name itself that parallel vector are those vectors whose lines of action are parallel. Yes. You know, vector we show by this, like this. Arrow denotes the direction. Length of this line segment denotes magnitude. Yes, Sagarika, yes, name. So this is called as line of action. Line of action. और जितनी इसकी लेंथ होती है उतना उसका वेक्टर का मैग्नीट्यूड होता है. ठीक है. More lengthy, more magnitude. Short length means less magnitude. This. So there are suppose two vectors. So if they are lines of action, these lines are parallel, then they are called as parallel vectors. So two vectors whose lines of action are parallel are said to be parallel vectors. Okay, this is, for example, if I want to show, these are parallel vectors, and parallel means that opposite also direction will work. This is example one. One more example if you want to write. This one is one vector, this is another vector. So same direction or parallel opposite direction. This also can be another definition. That second definition, if you want to say, two vectors are parallel vectors if their directions are either same or opposite, because in both the cases they will be parallel. Correct. And one more thing you should know, that vectors, suppose this is a vector containing 5 unit magnitude and this side direction, east direction suppose. So either you draw this here, or if you uplift it and draw somewhere here, suppose this is A vector and this is B vector, then both will be same only. तो वेक्टर आप उठा के कहीं और रख दे, उससे कोई फर्क नहीं पड़ता, बस उसका मैग्नीट्यूड वही रहना चाहिए, उसकी डायरेक्शन वही रहनी चाहिए. So that vector remains same only, right? Same way here, suppose these two are parallel vectors. So if you lift it and keep it here, suppose these two are parallel vectors. Suppose its magnitude is 5, its magnitude is 10. What you do? You this 10 wala you keep like this, and 5 one you take it and keep it here. Then it will become a straight line. It will become a straight line. That is why there is one more name of these parallel vectors. They are also known as collinear vectors. Parallel vectors are also called as collinear vectors. समझे? कोलिनियर वेक्टर्स. और एक बात कि इन दोनों के बीच फर्क क्या होगा? डायरेक्शन वही है, तो फर्क बस मैग्नीट्यूड का होगा. तो मैग्नीट्यूड का फर्क होगा, तो one vector is A and other vector is B. Then if you multiply with some constant, you may get the other vector. So their relation, one more note, this was note 1. Note 2, that if A vector and B vector are collinear vectors, of course parallel vectors, another meaning, collinear vectors, then A vector equal to lambda times B vector, where lambda is some constant. Right? Suppose direction is same, then lambda will be positive. And if suppose direction is opposite, then lambda will be negative. So the thing is that two vectors, if they are collinear, or the same direction or opposite direction, then they will have this relation. Right? Up in the exercise, such questions are there where some two vectors are given. They will ask you to prove that they are collinear. So you have to establish this relation, that one vector should be written as something into other vector, right? So that is collinear. So इसको हम use करेंगे. Now some more terms are there, like components. First of all, suppose there are three axes, O, X, Y, and Z, and suppose there is a vector. Suppose A vector. Then A vector, if its component, that A vector is like this. Its component along x-axis is A1. This is A1. Its component along y-axis is suppose A2, and its component along z-axis is A3. Then this vector can be written as A1i plus A2j plus A3k. Right? Of course, you must be aware of the meaning of I cap, j cap, k cap. What are I cap, j cap, k cap, friends? Where I cap, j cap, and k cap are what, students? Unit vectors along x-axis, y-axis, and z-axis respectively. Then A1 is called as x component, A2 is called as y component, and A3 is called as z component. Correct? Right? And they are called as scalar components along z-axis or along y-axis or along z-axis or along x-axis. Right? But if you take A1i, then that is called as vector component along x-axis. Right? Vector component along x-axis will be but we need to understand them. Along x-axis it will be A1i cap. Right? This will be vector component along x-axis. This is. Now, its magnitude, let us learn how to get it. So, vector A, its magnitude will be denoted by this sign. Enclose the vector within modulus sign. This you know, or A you write simply. Then to calculate its magnitude, this will be equal to root of A1 square plus A2 square plus A3 square. Right? So suppose some vector is given, its magnitude you need root of I multiplier square plus j multiplier square plus k multiplier square. Right? And if you understood, let me ask one question. Suppose that some A vector is I cap plus 2j cap plus 3k cap. Then tell me what should be its magnitude? Somebody tell me, Mohit Sharma, can you tell me what should be its magnitude? Mohit Sharma or Monisha Ghosh? Monisha and Mohit, are you there listening me?
Root 14.
Yes. Are you Mohit?
Yes, sir.
Okay, Mohit. How much? Root 14. कैसे निकाला Mohit? Root of I think 1 square plus 2 square plus 3 square is this. 9 plus 4 plus 1. 13 plus 1, 14, right? Root 14 is the magnitude. So easily you can calculate by using this formula, right? Correct. One more thing, very small thing, that is understand. Suppose there are 2 points. There is a point, suppose capital A, and its coordinates are x, y, and z. Suppose this is a point, and you want to write OA vector, right? Then you know there is a name for OA vector. It is called as position vector of A. Position vector of point A. This is OA vector, and it is given by xi cap. Means what you do in x coordinate, you attach I cap plus yj cap plus zk cap. This is the way, right? And similarly, suppose there are 2 points. These are very basic things, very small things, and going to be used in the current chapter exercises, and then in the next chapter also these things are going to be used. Suppose there are 2 points. Suppose there is a point A and there is a point B. Suppose this is OA vector, this is OB vector, and this is AB vector. Right. Then there is a concept of vector addition. Let A and B are any 2 points. Then OA vector, OA vector plus AB vector. This is going to be equal to OB vector. And using this, if you shift one term on the other side, so AB vector can be calculated as OB vector minus OA vector. So this you can keep in mind that 2 points are there. Suppose AB, then OB vector will be position vector of B minus position vector of A. Position vector, in short I am writing PV. Position vector of B minus position vector of A. This is. So suppose 2 points are there, their position vectors are given, then the vector joining them you can find out. This is. Now let us learn. Suppose A is x1, y1, z1, suppose, and B is x2, y2, z2. Then A is x1, y1, z1, and B is x2, y2, z2. Then what should be AB vector? Can someone tell me? What should be AB vector? Yes, Nutan.
Z2 I cap plus Z y sorry X2 I cap plus Y2 J cap minus X I cap Y J cap Z K cap.
I'm not getting. Can you repeat it? Nutan, can you repeat? I'm asking, suppose A and B are the coordinates are given, and AB vector I have to find. This is the formula. AB vector is position vector of B minus position vector of A. Position vector of B will be how much? Position vector of B will be x2i plus y2j plus z2k. Right? Minus position vector of A will be x1i plus y1j plus z1k. Then Newton, if I subtract them, then what will come? The notable thing is that
I cap.
ith multiply I can be taken common in simple words, and if you take I common, x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap, you'll get this is AB vector. Right, correct. चलो मैं एग्जांपल से पूछता हूँ. ये एग्जांपल, let a is equal to 1 2 3 and let b is equal to 4 5 minus 9. Now tell me what should be AB vector. Among the boys, anyone? Pratham, can you tell? Pratham or Priyanshu Yadav? What should be AB vector? Yes, Nutan. What should be AB vector?
3 I cap plus 3 j cap minus 12 k cap.
क्या बोला? 3 I cap
Plus 3 j cap plus 3 j cap
plus
3 j cap
j cap और
minus 12 k cap
minus 12.
k cap.
4 minus 1 is 3, 5 minus 2 is 3, minus 9 minus 3 is minus 12 k cap. बिल्कुल. This is the way how we can write AB vector. ठीक है. इसका मॉडुलस निकालना पड़ जाएगा. वो भी आप निकाल सकते हैं by root of 3 square plus 3 square plus minus 12 whole square. है ना? This is simple thing. This thing is getting completed. Then let us learn very small some more concepts. Then we shall move towards the exercise. There is a term called as direction cosines. Direction cosine. Cosine is मतलब cos. Take it. Let a vector makes alpha, beta, and gamma angles with x, y, and z axes respectively. Are you imagining that three axes are there? X axis, y axis, and z axis. Then there is a vector which makes alpha angle with x axis, beta angle with y axis, and gamma angle with z axis. Then if you take their cos, whose cos? In angles के. In angles के अगर आप cos ले लें तो वो कहलाते हैं direction cosine of vector. Then cos alpha, cos beta, cos gamma are called as direction cosines of the vector. Right? And I will give you examples of two-dimensional cases there. Suppose this is one vector, and this angle is alpha, and this angle is beta. And if you calculate cos square alpha plus cos square beta, suppose only two dimensions are there. So can you tell if beta or alpha में एक relation है? Beta will be how much? Can you tell? Students, beta will be how much?
Sir, figure is not visible.
हैं? कितना सौरभ?
90 minus alpha.
90 minus alpha. तो अगर मैं इसको यहाँ पे रख दूं, सिर्फ टू डायमेंशन का केस ले रहा हूँ, मैं ये जानना चाहता हूँ कि cos अल्फा, cos बीटा, cos गामा में कोई रिलेशन है कि नहीं है? तो सिर्फ टू डायमेंशन अगर है तो इसका स्क्वायर इसको ऐड करेंगे और बीटा की जगह अगर आप रख दीजिए 90 माइनस अल्फा, और जैसे कि आपको पता है cos 90 माइनस अल्फा इज sin अल्फा, तो ये बन जाएगा cos स्क्वायर अल्फा प्लस sin स्क्वायर अल्फा, जो कि कितना होता है? जो कि 1 होता है. तो similarly for 3 dimension also we can prove it. Proof डिस्कस नहीं कर रहे हैं, डायरेक्ट लिख रहे हैं कि cos square alpha plus cos square beta plus, this was just one idea how to prove it, plus, and this is true for 3 dimension also, plus cos square gamma is equal to 1, right? And these direction cosine, in short, we call them DCs also. So DCs, 3 numbers, they have a relation among them. Relation is that sum of their squares is 1, right? And using this relation, you can check that whether those any 3 numbers are DCs of some vector or not. So, for example, can they be DCs of some vector? Can you tell? Are they DCs of some vector? क्या कोई ऐसा वेक्टर होगा जिसके ये DCs हो सकते हैं? क्या ये DCs हो सकते हैं? डायरेक्शन कोसाइन हो सकते हैं? Students, is it possible to check? Can they represent some direction cosines of some vector? No, they cannot. Why? Because if you find sum of their square, it will not be 1. It will never be equal to 1. So this cannot be DCs. But if you take 1 upon root 3, 1 upon root 3 and minus 1 upon root 3, can they be DCs of some line, some vector? They can be. Because if you find their sum of squares, it will give you 1 by 3 plus 1 by 3 plus 1 by 3. Sum of squares you find. This will be 3 by 3, which is 1. So 3 by 3 is 1, which means that these may be the direction cosine of some vector. ठीक है, तो डायरेक्शन कोसाइन निकालने के लिए वो वेक्टर हमें क्वेश्चन में गिवन होगा that एक वेक्टर x एक्सिस से this much angle is creating, y एक्सिस से और z एक्सिस से भी एंगल्स गिवन होंगे, उनके causes ले लीजिए, डायरेक्शन कोसाइन आपको मिल जाएंगे. Now often these direction cosine come in vector form, fraction form. So many times we make them simple. जैसे हम इसमें √3 से मल्टीप्लाई कर सकते हैं और उनका रेशियो ले सकते हैं, राइट? Like रेशियो इनका लेंगे तो 1:1:-1 आएगा. That is called as direction ratios. So let us learn one more term, direction ratios. These are the ratios of DCs, simple words, or you can say that these are the numbers which are proportional to DCs, right? DCs are DRs. DRs may not be necessarily DCs, because DRs, their sum of squares, if you find, it may not be 1 always. So this is right. These two things clear. Now there's a term called as addition of vectors. There are 3 operations. जिनमें numbers हैं, numbers पे आपने operations पढ़े हैं, adding them, subtracting them, multiplying them. अपने matrices के operations पढ़े हैं, आपने sets पे operations पढ़े हैं. So similarly, operations on vectors. And we will discuss 3 operations. The first operation is addition of vectors. And addition of vectors, just in the past also we used also that suppose this is a vector A and this is a vector B, and if you have to add them, then there's a method known as triangle method. What we do, any vector you take, suppose this vector B vector I have taken, draw it and then lift this A vector, and lifting and keeping it somewhere else will not change it. Of course, its length of this line segment we have to keep same, direction we have to keep same, and this vector you lift and put it here parallel to the direction which is given. Length also should be same only. This is A vector. Then if you connect them like this, then this vector will be B vector plus A vector. Right? So this is the way how we can add two vectors. Friends? And if you keep A vector here and B vector if you bring here, and then you join them, then A plus B you will get, and you will get verify that actually A plus B and B plus A both directions will be same only. So this also I can write some note about addition. Then addition of A vector followed by B vector will be same as B vector plus A vector. Do you remember what this law is called? Any one of you, boys or girls of B section, do you know what is the name of this law? Huh? Anyone? Aditya, Aman or Amit Kalwasra? Do you know what is the name of this rule? We have studied in chapter 1 while discussing binary operations. Arpita, do you remember what is the name of this? At least say yes or no.
Transversive.
No.
Commutative.
Yes. What?
Commutative.
Commutative law. तो वेक्टर एडिशन इज कम्यूटेटिव. जैसे बात तो हमें पता चल गई, लेकिन इसको हमें बोलना भी आना चाहिए कि पूरा वर्ड्स पूरे डेफिनेशंस का यूज करते हो प्रॉपर टर्म्स का. So that's why I request you that keep writing, students. Writing will make the things more clear. So that is vector addition is commutative. Vector addition is commutative. ठीक है, वेक्टर एडिशन कम्यूटेटिव होता है, आप इसको वेरीफाई कर सकते हैं. और एक प्रॉपर्टी कि सपोज देयर आर 3 वेक्टर्स, देन फर्स्ट यू ऐड B and C vector, then whatever result comes in that you add A vector like this, or you do first A and B vector you add and then plus C vector you do, both will be same. That also can be verified, right? So without changing the position, here I have not changed the position, I have kept A on first, B on second, C on third only, but grouping I have changed. This is also true for vector addition. You know what's the name of this law? Anyone in the class remembers? Irapa Sagarika is writing associative law.
Sir, associative.
Yes, that is vector addition is associative. हमें बोलना भी आना चाहिए पूरा उसका प्रॉपर टर्म से. Vector addition is associative. ठीक है. और एक नोट कि A vector plus 0 vector will be same as 0 vector plus A vector will be same as A vector. So 0 vector is additive identity. Right? And A vector plus minus A vector will be 0 vector. So minus A vector, पर इस आपको कट रहा है, देखिए let me make the camera position proper. Yeah. Here minus A vector is additive inverse of A vector. Right? अब ये माइनस A वेक्टर क्या होता है? ये स्केलर मल्टीप्लिकेशन हमने यहाँ पे किया है -1 का A वेक्टर के साथ, वो हम नेक्स्ट अभी ऑपरेशन में डिस्कस करने जा रहे हैं डिटेल. ठीक है, तो ये तो हो गई वेक्टर एडिशन की प्रॉपर्टी. टू वेक्टर्स को ऐड कैसे करते हैं? ट्रायंगल मेथड से ऐड करते हैं. ठीक है, एक और एग्जांपल से बात कर लेते हैं. कंपोनेंट्स अगर दिए हो तो कैसे ऐड करेंगे. ठीक है, उसके बाद इस ऑपरेशन को क्लोज करेंगे. लेट A वेक्टर is I minus 2j minus 3k cap, and let B vector is minus 2I minus 3j plus 6k. Then A plus B vector will be how much? Actually ये मैं बस इसलिए एग्जांपल दे रहा हूँ कि जिससे ये क्लियर हो कि कंपोनेंट वाइज हम एडिशन करते हैं. ठीक है, यू कैन से कि I कंपोनेंट जाके I कंपोनेंट में ही ऐड होगा. यू कैन से इन अदर वर्ड्स कि हम I कॉमन ले सकते हैं. तो कितना आएगा अगर आपको बात समझ में आई? व्हाट शुड बी फाइनल? A plus B वेक्टर.
सर दिख रहा है साइड से.
यस
सर साइड पार्ट नहीं दिख रहा है.
क्या side?
सर साइड में नहीं दिख रहा है.
No, it is clear. Only this much is written. I also can see. No. Yes. So a plus b vector will be how much? I minus 2i will be how much? Minus I.
minus I minus 5j
Yes.
plus
And
3k.
तो मैं ये कह रहा हूँ कि सपोज वेक्टर्स इस टाइम में दिए हैं, इसको बोलते हैं कंपोनेंट वाइज. वेक्टर्स आर गिवन इन कंपोनेंट्स, देन their respective components can be added. I multipliers can be added, j multipliers and k multipliers. That is ठीक है. तो ये पूरी बात हो गई वेक्टर एडिशन. नेक्स्ट पॉइंट है स्केलर मल्टीप्लिकेशन. I request you all that you can note it. Although things are super simple, once or you start learning, you will get the things, but you will get confidence if you write in your notebook. Right? Writing will make it perfect. So keep writing spreads. Then second operation is scalar multiplication. Scalar means number. Scalar, second operation is scalar multiplication. Scalar multiplication means let a vector is a1i plus a2j plus a3k and k belongs to R, is a real number. Then ka vector will be multiplied with every component, ka1 into I cap plus ka2 into j cap plus ka3 into k cap. This is right. And here also some properties are there. That suppose there are two vectors, a vector plus b vector, and one scalar, you multiply with k, then it will be equal to ka vector plus kb vector. Something like distribution law. यहाँ पे k क्या है? K is a real number. This is one note. Another property is that suppose two numbers are there and one vector is there. यहाँ पे क्या था? दो vector थे, one scalar था, one number था. तो डिस्ट्रीब्यूशन लॉ हो गया. यहाँ पे भी डिस्ट्रीब्यूशन लॉ काम करता है कि दिस विल बी k1 a वेक्टर प्लस k2 a वेक्टर, वेयर k1 एंड k2 आर रियल नंबर्स. और यही बात मल्टीप्लिकेशन में भी ट्रू रहती है कि सपोज k1 k2 together you multiply and then multiply with a vector, this will be same as first k2 you multiply with a vector and the resultant you multiply with k1. That also quite true. Both are same. So these are the properties of scalar multiplication. The next property, the next operation is product of two vectors. That contains more stuff. We'll discuss on next time. But this is the time to discuss our first exercise, which is super easy. So I am sharing the screen with you people, and I request you students to answer those questions. For example, be ready. I hope this screen must be visible to you. Tell students, is it visible to you? Someone please tell, is this visible to you?
No sir.
No sir.
Not visible?
Yes, sir.
No sir.
Maybe शायद पिन कर लीजिए अगर नहीं दिख रही है. But I hope this must be visible to you. Students, is this visible?
Yes, sir.
Yes, it must be visible. Exercise 10.1 is there in front of you. First question is represent graphically a displacement of 40 kilometer 30 degree east of north. So you know how to do it. You have to draw a graph actually, draw the vectors on your notebook actually. Right. I can show you on board that how to do it. Represent graphically a displacement of 40 kilometer 30 degree east of north. So let us see this. Yeah. I hope you know northeast. This is east, this is west, this is north, this is south. So let me draw east of north. Where is east of north? This is north, right? But 40 kilometers east of north means in this side 30 degree to make. This is 30 degree and this
Sir,
direction
graph out of
you
board.
write it 40 km you write it. Check.
Sir, graph
Yes.
out of board.
Yes. Let me make it proper. Yeah, I hope now it should be visible to you. Right, students? So you can check read the question and you can check. Question was 40 kilometer where we have to draw 30 degree east of north. So north is this 30 degree in east side. East side I have made 30 degree, then draw a line segment, make an arrow, and you write 40 kilometer. 40 kilometer we cannot draw in actual on paper. So it's some line segment you draw and call it 40 kilometer, right? Simple it is. Then let us move towards the next question. The next question is 1 minute. Yeah, second question. Second question is classify the following. This you can tell. You tell this, right? Classify the following measures as scalars and vectors. First one, 10 kg.
Scalar.
Scalar quantity, obviously. Then second one,
Vector.
vector quantity. Others also speak. See, if you participate, it will create more interest. 40 degree.
Scalar.
एंगल क्या
Scalar.
स्केलर क्वांटिटी रहेगी है ना एंगल्स आर स्केलर क्वांटिटी 40 watt
Scalar.
Scalar.
watt is actually क्या फॉर्मूला था watt का power upon energy divided by some formula is time no so wattage is also wattage is actually potential unit of potential. I'm missing forgetting. So but this is a scalar quantity. Coulomb is the unit of
Scalar.
what? Scalar quantity is unit of what? No, it is unit of what? Coulomb is the unit of what? Charge, right? Charge is scalar quantity. 20 meter per second square. So you should identify
Vector.
acceleration, unit of acceleration. This is scalar vector quantity. Question 3. Classify the following as scalar and vector quantity. Time period.
Scalar.
Scalar.
Distance is also a scalar quantity. Third, force. Force already we have discussed. Vector quantity. Velocity. Vector. Work done.
Scalar.
Scalar.
Fourth question is that one figure is given. I hope it is visible to you. And they are asking that identify the following vectors. Co-initial we discussed. Equal. Equal word we did not write, but you can understand. Equal vectors will be those vectors which have same direction, same magnitude. So can you tell me which are two co-initial vectors in this given figure?
A and D.
A and D.
They are co-initial. Equal, which one two are equal? They are magnitude.
B and D.
A and D.
A and
B or D.
D equal
and D.
direction अलग है.
B
A
and
and
D.
B or D.
B और D है equal, correct. और third है collinear but not equal.
A or C.
A and D.
A or C.
A and C.
A और C collinear है because they are parallel, but equal नहीं है क्योंकि उनकी directions opposite है ना? तो इस तरह से बहुत I request although they are easy but please write them in your notebook, right? Easy का मतलब ये नहीं कि you skip them. You please write them because you may have doubts. Similarly, question 5th is there. Answer the following which is true or false. Tell me A and minus A are collinear. Is it?
True.
True. Yes,
True.
sir.
B. Two collinear vectors are always equal in magnitude. Is it?
False.
False.
No. Their direction will be same, but magnitudes may differ. Third part is two vectors having same magnitude are collinear.
False.
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 Two collinear vectors having same magnitude are equal.
False.
false
False.
उनकी डायरेक्शन अपोजिट हो सकती है. Thank you so very much for attending this class and please complete in the next exercise. In the next class we will discuss the next exercise. Thank you. We are getting.
Sir, attendance.
I'll export this attendance and will mark your attendance. Thank you so much.
Thank you,
Yes.
Thank you,
sir.
sir.